So let's start talking about the activity series. Now that we know how to predict the types of products and the types of reactions that we have, let's look specifically at the activity series and how it's used in single replacement reactions. Now, what is the activity series? The activity series is a list of metals with increasing reactivity. Basically what this means is that the most reactive is on the top of the list. So we see lithium's up here. It's on the very top. It's the most reactive metal. The least reactive metal will be on the bottom, so we see that gold is way down here, and so it's the least reactive metal. So the most is on the top, the least is on the bottom. And the way that it works is that when you have something that is on top, it likes to react more and will actually switch places with something that's below it. So how can the activity series help predict the chemical reaction? Remember, again, it's only for single replacement reactions. We don't use it for anything else. And if pure element is higher on the series, it will replace the cation in the compound. So if the element in a single replacement reaction, the element plus a compound, if the element is higher than whatever the cation is. So when we have the metal that's bonded in that compound, if it's higher up, the element, then the reaction occurs. If the single element, so the element is lower on the activity series, no reaction occurs. So if you're on top, say lithium, lithium can replace anything below it. Okay? But zinc can replace anything below it, but nothing above it. So if zinc is the single element, it cannot replace magnesium, aluminum, or manganese, aluminum, magnesium, sodium, calcium, barium, potassium, or lithium. Can't replace anything above it. Okay, so whatever by itself, if it's on top of the cation, the reaction happens. If not, then no reaction. So let's look at an example. So let's predict if the reaction between barium and zinc nitrate would occur. And if the reaction occurs, then predict the product of the reaction. So we have barium, which is Ba by itself. Is it a diatomic? No, it's not, so we don't put a 2. Okay, and then we have zinc nitrate, which we have zinc, which is +2, nitrate, NO3, -1, crisscross to make the compound. So we have Zn, NO3, 2. So there's our possible reaction that we have. So we're trying to look and see, will this reaction actually happen? When we look at it, barium, where is it? Barium is right, try to find it right there. Okay, and where's zinc? Zinc is way down here. So since barium is on top of zinc, okay, because we're looking at the metal, metals replace metals, non-metals replace non-metals, barium is on top of zinc, then the reaction occurs. So zinc is now by itself, and barium is now bonded to nitrate, which we have barium, which has a +2 charge, nitrate, which is NO3, -1, crisscross, and we get BaNO3, 2. Okay, that reaction actually happened. Let's look at the next one. It says predict the following equation. Can it occur? And if it does occur, then predict the product of the reaction. So we write it out. We see that we have magnesium, which is just Mg by itself. It's not a diatomic, so we just leave it as Mg, plus our calcium, which is Ca, bonded to carbonate, which is CO3. Okay, this has a +2, -2. Since it's a 2-to-2 ratio, we crisscross the 1s because they reduce. The 2 came down here, 2 came down there, but we reduce it down to CaCO3. So we look for it. Where is magnesium? Magnesium is right here. Okay, it can replace anything below it. Where's calcium? Well, calcium just tends to be above it. So since calcium is above magnesium, magnesium cannot replace calcium. So therefore, we would just say that no reaction. Looking at this one, predict if the following equation can possibly occur, and if the reaction does occur, then predict the product. So we have barium trying to replace iron. So we'll find barium. Barium is way up here. Can it replace iron? Which iron is going to be right there. It's below it. So since barium is on top, it replaces it. So iron is now by itself, plus barium is not bonded to nitrate. So we have barium plus 2, nitrate, NO3, -1, crisscross, and we get BaNO3, 2. And that reaction actually happened.